Okay, let's do problem 31 on page 326. Enough. I don't know. I think it was 914 days till retirement. All right. So, well, here's what's given. I'm just going to save a little time, just say, okay, that's what's given up there. And we know the radii and the forces. And this is kind of a wheel and axle system. So what are we trying to find? I'll just go that stuff. Well, we want to find the net torque. Okay, now let's solve it. Well, the net torque is just given to be the sum of all the individual torques. And so what we're going to do is I'm going to set this up as X, Y, and Z coming out of the paper. And I'm going to just add up the torques. So this is going to be equal to, look at the 10 and the 9. The 10 Newton force is, if I use the right-hand rule, you have R cross F. There's the R cross F. And it's trying to make it spin in the negative k hat direction. So that's going to be, it's the R, well, the R is B, which is 25 centimeters. And I'm just going to go ahead and make the change to meters. And then times the force. So R cross, well, this is, like, if I want to be really Ri cross Fi. And remember, the I here is an index. It's not an initial or final. I equals 1 to n or whatever. And so the cross product. Now, you don't really need to worry about like sine of 90. That's equal to 1. Whenever you have a wheel and axle system like this, the string always comes off tangential to that, and therefore the angle is always 90 degrees. Now this is in the negative k hat direction. And then just to make it fit on my paper, I'll just go plus the next one. Well, we'll do this one. That's also 0.25 meters. And it's 9 newtons in the negative k hat direction. And then plus, what do we got here? We've got this little one. We got, well, it's a small radius, 0.10 meters. And the force is 12 newtons. But this is in the positive k hat direction. If you look at this torque, it's trying to make the wheel spin counterclockwise. So my thumb comes up when I spin it around. So this is, well, this is 2.5 Newton meters, negative k hat. And then what is 9? 9 times 0.25 is 2.25. Negative k hat. And then this is 1.2 Newton meters in the k hat. So what I'm going to do is just add those together. Plus 2.25 and then minus 1.2 equals, and you get your answer is the net torque is 3.55 Newton meters in the negative k hat direction. So I think the biggest mistake people make on this problem is forgetting that this torque is in the opposite direction. So the torque from the 12 Newton force here. And so, these two add together, but this one subtracts from it. And then also keeping track of what direction they're in, into or out of the paper. I suppose as long as you establish an axis system and stay consistent with it, this could be anything based on what you assume. But this is just kind of the standard assumption in this class, that if you have a picture like this, there's horizontal is X, up is Y, and then out of the paper is Z. Any questions? That is all.